चलिए बच्चों, so let's talk about carboxylic acid बच्चों. First of all, you need to understand us why carboxylic acid is too important. क्यों है इतना important? क्योंकि हर एक चेन, जो हर एक लूप में बनी हुई चेन एंड होती है, वो एंड होती है कार्बोक्सिलिक एसिड पर. फॉर एग्जाम्पल, अगर आपके पास अल्केन है, so you know that कि आप इस अल्केन को कन्वर्ट कर सकते हो अल्कीन में. You know that आप इस अल्केन को कन्वर्ट कर सकते हो हेलोजिनो अल्केन में. और उसके बाद ये अल्कीन किस में कन्वर्ट हो सकता है? अल्कोहल में कन्वर्ट हो सकता है, या ये आपके पास अल्कोहल में कन्वर्ट हो सकता है, या ये हेलोजिनो अल्केन भी आपके पास अल्कोहल में कन्वर्ट हो सकता है. और फिर ये अल्कोहल, अगर ये अल्कोहल प्राइमरी है तो ये अल्कोहल किस में कन्वर्ट हो सकता है बच्चों? ये अल्कोहल कन्वर्ट हो जाता है कार्बोक्सिलिक एसिड में, है ना. उसके अलावा अल्कोहल कैन बी कन्वर्टेड इनटू एल्डिहाइड एज वेल, और फिर ये एल्डिहाइड भी कार्बोक्सिलिक एसिड में कन्वर्ट हो जाता है. ये आपने देखा इस चैप्टर में, राइट. अब तक आप ये सारे कनेक्शंस देख चुके हैं. उसके अलावा आपको ये भी पता है कि आपके पास ये जो हेलोजिनो अल्केन्स थे, हेलोजिनो अल्केन्स किस में कन्वर्ट होते हैं? हेलोजिनो अल्केन नाइट्राइल्स में कन्वर्ट होते हैं, और नाइट्राइल्स भी किस में कन्वर्ट हो जाते हैं? कार्बोक्सिलिक एसिड में. सो हर एक चेन का एंड जो हो रहा है बच्चों, वो कार्बोक्सिलिक एसिड पर हो रहा है. That is why this homologous series, this topic is very important for you to complete your questions in paper 2, right? तो ये आपको पता होना जरूरी है. That is why we are going to talk about this in today's class, right बच्चों?
Yes, sir.
कार्बोक्सिलिक एसिड है क्या बच्चों? कार्बोक्सिलिक एसिड एक्चुअली ये देखें, C डबल बॉन्ड O और इसके साथ अटैच्ड ये OH. यहाँ पर कार्बन की कोई भी चेन हो सकती है, CH3, CH3, CH2, कुछ भी हो सकती है. So this is actually carboxylic acid, right? You need to keep remember this. ये carboxylic acid है. Now you need to make a difference in carboxylic acid, in esters and alcohols as well. देखिए, अगर कार्बन डबल बॉन्ड ऑक्सीजन और उसके साथ ऑक्सीजन अटैच हो, और इस ऑक्सीजन के साथ H की जगह पर कोई कार्बन चेन अटैच हो, और यहाँ पर भी कोई कार्बन चेन अटैच हो, दिस इज बच्चों व्हाट? दिस इज एस्टर. बट इसमें ये डिफरेंस क्रिएट रखना है, आपने जहन में रखना है कि C डबल बॉन्ड O और O के साथ कोई कार्बन चेन अटैच है. लेकिन अगर C डबल बॉन्ड O और उसके साथ O अटैच है और उसके साथ H अटैच है, यानी कि ये लास्ट में लगा हुआ है, एंड में लगा हुआ है, या शुरू में लगा हुआ है, वो भी एंड में लगा हुआ होगा तो H लग सकता है. ठीक है, अगर बीच में लगा हुआ होगा तो H नहीं लगा हुआ होगा, तो वो एस्टर होगा. अगर कोरे पे लगा हुआ होगा तो कार्बोक्सिलिक एसिड होगा. और बच्चों, अगर सिर्फ और सिर्फ क्या लगा हुआ आपके पास? C डबल बॉन्ड O लगा हुआ और दोनों तरफ ही आपके पास कार्बन चेन्स हो, तो बच्चों दिस इज कीटोन, राइट. और सिर्फ अगर आपके पास OH लगा हुआ विदाउट डबल बॉन्ड ऑफ कार्बन एंड ऑक्सीजन, देन इट इज अल्कोहल, राइट. और उसके साथ साथ आपको ये याद रखना है कि अगर आपके पास C डबल बॉन्ड O हो और उसके साथ अटैच H हो और फिर कार्बन की चेन हो, तो दिस इज एल्डिहाइड. तो फर्स्ट ऑफ ऑल यू नीड टू रिमेंबर बच्चों कि मैं किस तरह किसको आइडेंटिफाई करूं. अगर आपको आइडेंटिफाई करना नहीं आता, तो डेफिनेटली इट विल बी डिफिकल्ट फॉर यू, कि आपको पता ही नहीं है आप कर क्या रहे हो. ठीक है ना, आपको यही नहीं पता कि मैं एल्डिहाइड से अल्कोहल में जा रहा हूँ या मैं कार्बोक्सिलिक एसिड से अल्कोहल में जा रहा हूँ. तो इफ यू डोंट नो दिस, so you cannot apply the reagents, you cannot apply the conditions for this ना. तो सबसे पहले तो आपको ये पहचानना पड़ेगा कि हम जा किससे कहाँ रहे हैं, उसके बाद फिर आप अप्लाई कर सकते हैं कंडीशंस, राइट. तो इस वक्त हमारा जो टॉपिक है वो क्या है बच्चों? कार्बोक्सिलिक एसिड. दिस इज द कार्बोक्सिलिक एसिड दैट वी नीड टू लर्न इन टुडेस क्लास, राइट. सो लेट्स मूव ऑन विद कार्बोक्सिलिक एसिड, राइट. Now let's talk about something like the nomenclature of carboxylic acid. How can we write the names of carboxylic acids? Now, so for this, you need to remember this. But so, for example, we have 1 carbon, 2 carbon, 3, 4 carbons, and we have carboxyl group and O and H. Here we have H. Here we have H. H, 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 and H. So how can we write the name for this? So remember, bacho, you need to select a longest chain. First of all, you need to select a longest chain in which the carbons are going to be present, right? And that carbon is also present over there where which is going to form carboxylic acid. You can see this. This carbon is having carboxyl group, right? So in the long chain, there should be this carbon. Right now, we have this straight chain, so we can have these 4 carbons, right? So what is the name of this compound? We have 4 carbons. 4 carbons को बच्चों क्या बोलते हैं हम? ब्यूट बोलते हैं, ठीक है ना? BUT, ब्यूट. और क्योंकि ये कार्बोक्साइल या कार्बोक्साइलिक एसिड है, इसको हम बोलेंगे ब्यूटेनोइक एसिड, ठीक है? एनोइक एसिड यूज करेंगे इसको कंप्लीट करने के लिए, इसका नाम रखने के लिए, ठीक है? We can have further problems like this. For example, if you have 1, 2, 3, 4, 5 carbons, and over here we have carboxylic acid group, and we have one branch as well. For example, branch as well over here. Now, what I was saying to you, but you need to select the longest chain in which the carboxylic acid functional group is present. Just look at over here. If you go from 1, 2, 3, 4, 5 carbons, it is the longest chain in which 5 carbons are over there. And if you go like 1, 2, 3, 4, 5, it is also the longest chain in which the maximum number of carbons are there. But what if we have like this? क्या होता अगर हमारे पास कुछ इस तरह से होता? This CH2 and CH3. Just look at over here. Now, if we have this condition, bacho, so we have 1, 2, 3, 4, 5. In this way, we have just maximum 5 number of carbons, but in this way, 1, 2, 3, 4, 5, 6. Now you can see this. This will have 6 carbons. So remember, you need to consider maximum number of carbon in the straight chain, right? This is the straight chain having the maximum number of carbon and also having the functional group of carboxylic acid. So what is the name for this? Remember, maximum number of carbons is 6, and as we have carboxylic acid, so we can write hexanoic acid. This is hexanoic acid, and we know that we have a branch as well, and it is of 1 carbon, so the branch name is methyl. It is methyl hexanoic acid. And we definitely need to represent the number of carbon on which the branch is present. So for this, remember, we need to start numbering from where the functional group is present. 1, 2, 3, 4. So it is actually 4 methyl hexanoic acid. Right, bacho?
Yes, sir.
Then we have one more problem with this. And the problem is actually along with alcohol functional group. Some of the MCQs and some of the molecules is actually having both the functional groups. Like for example, if you talk about the functional group of carboxylic acid along with the functional group of alcohol. So what's going to be happen? For example, if you have 1, 2, 3, 4 carbons, and this 4th carbon having alcohol functional group. But at the 3rd carbon, just look at over here, we have carboxylic acid. So this is the compound having 2 functional groups. Now for this, you need to keep remember which one is more important or which one is, you can say that, superior functional group over here. Remember, if you have alcohol and if you have carboxylic acid in a single compound, so the carboxylic acid will be like preferable compound or preferable functional group. So remember, you need to count maximum number of carbon in the chain having carboxylic acid functional group. Now it is 1, 2, 3, 4, right? This is number of carbon 4, and this is 1, 2, 3. So definitely 4 carbons are going to be selected. So these are maximum number of carbon that we can have in a single chain. So you can see we have 4 carbons. So you can say that it is actually butanoic acid. Carboxylic acid, no? It is butanoic acid. And I have told you from where You need to start numbering. You need to start numbering from where the functional group is near. So it is 1, 2, 3, and 4. So you can see this at 4, you have hydroxyl group. When it is not the main chain, so you need to consider this a hydroxy group, right? So you can see this, you have hydroxy at 4 hydroxy, right? And you have a methyl branch at number 2. So you can say that you have 2 methyl and 4 hydroxy. Now, इन दोनों में से कौन सा पहले रखा जाएगा? The one like having alphabet H, हम इसको alphabetically order में arrange करने वाले, ठीक है ना? So the alphabet which comes first in they are going to be written first, right? For example, H is, I think, come first now. So it is 4 hydroxy. M is after H, so it is 2 methyl and then butanoic acid. This will be the name of this compound, right, bacho? Right, bacho?
Yes, sir.
Thank you. Okay, then if you talk about the other things, so you need to remember this. Actually, the reactivity of carboxylic acid is dominated by the tendency of OH bond, right? That is going to be ionized in water when you are going to dissolve carboxylic acid in water. So they are going to produce like some partial H positive ions into the aqueous solution, and just because of that H positive ions in the solution, carboxylic acid are actually weak acids, like they are termed as weak acids. So you need to keep remember that if you talk about carboxylic acids, so carboxylic acid when dissolved in water, they are going to be partially dissociate. So actually the chemical properties of carboxylic acid are dominated by this partial dissociation or this tendency of OH bond, which is going to be break down in water or dissociate. So you will have what? This, and the H ion from OH is going to be break out and going to be dissociated, and this H will going towards water and having this H, that means it is hydronium ion, and whenever you find hydronium ion, it is actually in acidic behaviors, right? So carboxylic acid is actually acidic because it is losing H positive ion, or you can say that it is proton donor, right? And the second thing is it is weak acid because not all the H ions are going to be dissociated, few of them, or you can say that a very partial dissociation occur, right, bacho? Right, bacho?
Yes, sir.
And you need to remember this, that one of the topic in our syllabus is dative covalent bond, and according to this, oxygen have 2 lone pairs, right? And with a hydrogen in water, right? 2 bond pairs with hydrogen and 2 lone pairs that are not associated with any element. So when they find H positive, they just oxygen donate its lone pair to this H positive. When one-sided sharing occur, this is actually dative covalent bond, which is going to be seen over here. So you can write arrow over here to show the dative covalent bond. So this is actually hydronium ion that is going to be formed from water, right? So this is hydronium ion. You can see this, we have 2 bond pairs and 2 lone pairs. Whenever you have find 2 bond pair and 2 lone pairs, the angle will be 104. And when you have find like 3 bond pairs, these are actually 3 bond pairs and 1 lone pair, and 3 bond pairs and 1 lone pair are going to show you the angle of 107, right, बच्चों? I think अब तक आप लोगों ने याद कर लिया होगा.
Yes, sir.
ठीक है. Then so we have we should have an idea of boiling point as well. For example, if you talk about aldehydes, so aldehydes will have the boiling point like this, right? And if you talk about alcohol, so alcohol will be a little bit greater in like boiling points, and carboxylic acid will be the highest. So you can say that this is the carboxylic acid, right? You need to remember this. We are talking about the substances that have a similar MRs, right? We're not talking about someone who is having a greater MR from the others, right? So it will be like if you have aldehyde with one carbon, you can consider this line for this alcohol, one carbon and one carbon carboxylic acid, right? It will be like this. So it is actually boiling point, and this is actually the number of carbons. So you need to compare these functional groups on the basis of same number of carbons, right? Then you need to understand this that boiling points and melting points. Actually, melting point and boiling point क्यों ज्यादा होता है? The main सबसे important चीज जो होती है वो होती है hydrogen bonding, right बच्चों? So you can see this if you talk about boiling point, why they have higher boiling point. So actually they are forming hydrogen bonding. Actually they are forming hydrogen bonding within a molecule, within a single molecule. For example, if you have carboxylic acid like this, you know that oxygen due to the lone pair of electrons is partial negative and this is partial positive. And you have a second molecule of, for example, carboxylic acid. So they are actually like this. Two molecules together. So it is partial positive and it is partial negative, and the opposite charges attracts each other by a hydrogen bond. So you can see this, there is a hydrogen bond which is going to be formed within a molecule, within a same molecule. That is why they are having higher boiling points, right बच्चों? Right बच्चों?
Yes, sir.
Then if you talk about solubility, so solubility is also connected with like hydrogen bonding with, but with water, right? This is also with hydrogen bonding. It is concerned with the hydrogen bonding, but this time this is concerned with the water. For example, if you are considering any carboxylic acid group like this is one of the carboxylic compound. We know that this is partial negative, this is partial negative, and this is partial positive. So you can see this, that three different molecules of water can bond with these from these different three partial charges. You can see this, for example, if I have water molecule over here, so it is going to bond with this, right? And for example, if I have water molecule over here, so it is going to bond with this. And if I have water molecule over here, so it is going to bond this. Just look at over here, a single molecule having three different species which are going to form hydrogen bonding with water. So over here, one hydrogen bonding, over here, second hydrogen bonding, over here, third hydrogen bonding. तो एक ही मॉलिक्यूल में इतनी ज्यादा हाइड्रोजन बॉन्डिंग हो रही है, that is why it is highly soluble in water. But definitely जैसे इससे नंबर ऑफ कार्बन बढ़ते जाएंगे, नॉन पोलर बिहेवियर इस कंपाउंड का बढ़ता जाएगा, क्योंकि R जो है आपका CH3 CH2 CH2 बढ़ते जाएंगे तो उसमें नॉन पोलर बिहेवियर बढ़ता जाएगा, इंड्यूस डायपोल बढ़ती जाएगी, तो उसकी सॉलिबिलिटी आहिस्ता आहिस्ता कम होती जाएगी, राइट बच्चों? Then lots of things of this chapter you already done with that, right? For example, what I'm saying right now, I'm saying that you already did this thing, that primary alcohol can form carboxylic acids. You know this. Primary alcohol क्या बना सकते हैं? Carboxylic acid बना सकते हैं. You already know this now. There's one thing you already have learned in the previous chapter of alcohols, right? So you know that if you have a carbon having OH, and if it is the carbon which is going to attach with two other hydrogens, and any carbon chain, right? If you treat this with acidic potassium dichromate, right? Or even if you want to convert it directly into carboxylic acid, so you can even use the stronger oxidizing agent as well. But for both of them, you need to heat under reflux. So you know that it is going to be convert into carboxylic acid, right, bacho, or not? You already did this now. And if you want example for this, so you can see this. If you have CH3, COH and this H. And if you use any oxidizing agent over here, you will see this. This is going to be converted into carboxylic acid, right? Then, bacho, we have one more condition for this is you can even use, or you know this, bacho, the second chemical property, you know this. If you have aldehyde, so aldehyde can also be converted into carboxylic acid. For example, if you have aldehyde, not alcohol, if you have aldehyde, so you can use acidic potassium dichromate, or you can even use acidic potassium permanganate, or even you use going to use tolerance reagent or valence reagent. This is actually the test for aldehydes that you are going to learn in the next chapter. So you can use all these, and you can use heat under reflux for the first two. So it can be converted into carboxylic acid, right? Aldehyde can be converted into carboxylic acid. For example, if you have this functional group, this is aldehyde, right? If you apply any of the reagent from here, so it will be going to convert into carboxylic acid, right? If you want example for this, so CH3, CHO is one of the aldehyde. So if you apply condition, any one of them, so it's going to be converted into CH3, COOH, right? But this is also one of the chemical property that you already learned in alcohols, right? You know that primary alcohol is going to be converted into aldehyde first, and then they are going to convert into carboxylic acid. Then, bacho, one more thing you learned in the previous chapter, I told you, bacho, that if you have nitriles, for example, CH3, CH2, CN, if you have compounds like this, and you are going to hydrolyze them in the presence of dilute HCl or dilute sulfuric acid, so you know that it is going to be converted into carboxylic acid plus NH3, right, bacho? You need to understand this, or you need to understand this. You can even use dilute sulfuric acid as well, or you can even use NaOH or KOH aqueous as well. But for all of them, you need to do what? Heat under reflux. Now, there is one thing that is very important for you that you need to understand in the hydrolysis of nitriles. This is actually hydrolysis of nitriles that you need to understand, bacho. This is what, for example, if you are doing acidic hydrolysis, bacho, you know that you have CH3, CH2, CN, right? You just add water plus acid, right? And you just hydrolyze this. When you hydrolyze this, so you will find like आपके पास क्या होगा? आपके पास बनेगा carboxylic acid CH3, CH2, COOH plus ammonia बनेगा, right? So you need to remember this, बच्चों. This is actually acid, and this is actually the only basic gas, right? So if you have already acid in your chamber or in your container, so you will see this, that this H is going to be attacked on basic environment as well, right? So it will be like CH3, CH2, CN, kuch nahi hoga, right? This water will not going to be changed, but the acid present over there definitely affect the alkaline product, which is the final product over there. So it will make salt of this, right? It will make it salt, right? That, for example, if you are doing alkaline hydrolysis, for example, if you are doing basic hydrolysis, so definitely you are going to use NaOH over here. When you use NaOH over here, so definitely CH3, CH2, CN in the presence of water plus hydroxide ions, it is going to be changed into carboxylic acid, CH3, CH2, COOH plus NH3. But we know that this is acid and this is alkali, yeah, base, the only basic gas, right? So you know this, that when we have basic environment in the chamber, so definitely it can attack on the product which is going to be formed as an acid. So it will convert acid into the salt of acid, right? So it will be the salt, right? Which you need to understand this hydrolysis. If you are going to add so any acid, so the one of the product which is alkaline is going to be converted into the salt, and if you are doing alkaline hydrolysis, so definitely one of the product which is acidic is going to be converted to its salt. Right, Bacho? Is that clear?
Yes, sir.
Then, Bacho, I already told you about this as well, that alcohol and carboxylic acid, both of them can react with sodium as well, because sodium is highly reactive. So you can write over here, for example, if you have alcohol, right? So it can react with sodium, and we know that sodium is highly reactive, so it can displace the H from hydroxyl. So you will see that CH3, CH2O, and A plus half hydrogen gas will be formed. Same as it is in the carboxylic acid as well. For example, if you have CH3, CH2, COOH, and you are going to react it with sodium, so you will see this, that CH3, CH2, COO, and A will be going to form with hydrogen gas. The same thing, right? And I also told you in alcohols as well. For example, if you have any alcohol and you are reacting it with what? PCl5 at room temperature and pressure. So you know that one of the product is CH3, CH2, Cl. This is nucleophilic substitution along with HCl and POCl3, right? And we know that this HCl is actually from white fumes that are going to be coming from the presence of OH. And same as it is, if you have any carboxylic acid like CH3, COOH, if you reacted with PCl5 at room temperature, so definitely this PCl5 is going to attack on the hydroxyl again, and it is going to change it by Cl. It is also nucleophilic substitution along with HCl is going to be formed, and this is again going to form white fumes again, right? This is actually the test of hydroxyl ions. So you need to see this, that hydroxyl is also present in alcohols and hydroxyl is also present in carboxylic acid. So this is not the special test for carboxylic acid or a special test for any hydrogen. This is actually the test for OH functional group, which is hydroxyl, not ion. Sorry for this. Ion hota to ye hydroxide hota, it is actually hydroxyl. So ये hydroxyl का test. When you add PCl5 over there, they will form what? HCl white fumes, और इससे confirmation हो जाएगी कि HCl is one of the product over there, and this is all because of OH hydroxyl functional group, right? और hydroxyl सिर्फ और सिर्फ carboxylic acid और alcohol में मौजूद है. Is that right, बच्चों?
Yes, sir.
Then we have esterification as well, one of the very important and very interesting topic of this, esterification. You need to understand this, when alcohols react with carboxylic acid, they will form what? Esters plus water. And esters are very sweet smelling products. They are actually sweet smelling products. You can use them in perfumes, and you can even use them in flavoring something, right? So you need to understand this, how can we form this. Now before we are going to know about the formation, you need to remember the reagent. For example, if you are learning this in carboxylic acid chemical properties, so definitely the next thing which we are going to write is alcohol. You must need to add alcohol with sulfuric acid, right? You need to add concentrated sulfuric acid, because water is one of the product over here, and this is actually reversible reaction. So when sulfuric acid absorb water, this will decrease the amount of product, and it will move the equilibrium towards right hand side. That is why we are using concentrated sulfuric acid over here. And then condition is you need to heat it, or if you want to know the temperature over here, so you can heat it simply. Otherwise, you can write 60 degrees centigrade as well. Or you can say that this is nucleophilic substitution. This is nucleophilic substitution, right? Or you can say that it is the condensation reaction, because water molecule is going to be formed. It is condensation molecule, or the simplest one is esterification. These are actually the types of this reaction that you need to keep in mind for 1 mark, right? So let's talk about the structure of esterification. For example, we have ethanol, which is going to react with propanoic acid, which is going to react with propanoic acid. But if you don't mind, so can I write propanoic acid first? If you don't mind. For example, 1, 2, 3 carbon. There's this carboxylic acid. And if you don't mind, so can I write OH in this way? Then definitely we are going to react it with alcohols, and it will be the ethanol of 2 carbons. Can I write like this? Or C, C, and O, H, right? This is ethanol, right? So, bacho, remember one thing very important for you, that always carboxylic acid is going to leave or remove its OH for the water molecule formation and the H from alcohol. So they just combine together to form what? Water molecule. They're just going to combine together to form water molecule, bacho. So the water molecule is formed, right? And then what we have left, just look at over here. 1, 2, 3, 1, 2, 3, 4. And this is from carboxylic acid, left from carboxylic acid, right? And the left from alcohol is actually this, right, bacho? So this is the ester molecule. Remember this, when the bond of OH is breaking from alcohol, this bond break and this bond break. So this oxygen and this carbon going to connect together. This is going to form the ester linkage over here. You can see this carbon double bond oxygen with oxygen, and on both sides we have carbon chains. So this is actually the ester linkage that is going to be formed over here. Then you need to name this compound as well, which is a very interesting part of this structure. Remember this, the number of carbon in alcohol. We have 2 number of carbons in alcohol, so you can write it and you can write YL with this, it I. And the number of carbon in carboxylic acids are 3, so there's prop, and you need to write NO8 with this. So the name of this compound is ethyl propanoate. Ethyl propanoate, right, bacho? Is that clear?
Yes, sir.
Right. So let's talk about any other molecule. For example, if you have methanol, right? If you have methanol and it is going to react with ethanoic acid. So we know that what is the ester which is going to be formed over there. You need to remember this, that the carbon in alcohol, it is going to be right first. Just for example, methanol, so we can write methyl over there and 2 carbons over here. So it is methyl ethanoate, which is going to form with water molecule, right? So we know that methanol is actually 1 carbon alcohol and ethanoic acid is 2 carbon carboxylic acid. So you can see this is the carboxylic acid we have, right? And this is the alcohol that we have. Right. When they combine together, we know this, the H from alcohol and the OH from carboxylic acid is going to be removed to form the water molecule, right? And the rest of the substances, or you can say that the rest of the bond are remain same, and carbon and oxygen combine together only, right? Just look at over here, at this carbon double bond oxygen will remain same, this carbon hydrogen bonds are remain same, right? Same as it is, this carbon hydrogen bond remains same, and oxygen bond remains same. So the only bond which is going to form over here is this bond, right? And it forms what? Ester, right, bacho?
Yes, sir.
This is actually esterification. right? Now बच्चों, the homework task for you, even we can draw the substances like this. For example, if you have carboxylic acid with two hydroxyl groups, two carboxyl groups, right? And if it is reacting with alcohol and you have excess alcohol, for example, if I'm giving you the alcohol with 3 carbons, so what will be the ester that is going to be formed, right? This is your homework task. And for example, if you have alcohol, or if you have a compound having alcohol on both ends, right, and you are reacting it with uh, 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 for example, propanoic acid. So what will be the ester that is going to be formed over there? This is your homework, bacho, right? So you need to consider this, you need to complete this, and remember this. From the next class, we are going to start with hydrolysis of esters, right? We will start from hydrolysis of esters. Remember this. And if I asked you about this, you need to tell me this, that sir, we need to start from here. Okay, bacho. Is that clear? Every one of you?
Yes.
Okay, just take yourself. We'll see you again in the next class, inshallah. And it's all about